JEE Advanced 2021, Paper 1, Question 11. Physics, Rolling Motion. Let us visualize the setup. A cylindrical object of mass m and radius r sits on a rough horizontal surface. A horizontal force F is applied at its center of mass. The coefficient of friction between the object and the ground is mu. We need to identify which statements about its rolling motion are correct. The cylinder rolls without slipping. This means the point of contact has zero velocity. Friction acts backward at the contact point to provide the torque needed for rolling. The question asks, which of the following statements are correct? Option A, for the same F, the acceleration A does not depend on whether the cylinder is solid or hollow. Option B, for a solid cylinder, the maximum possible value of A is to mu g. Option C, the frictional force on the object is always mu mg. Option D, for a thin-walled hollow cylinder, A equals F over 2 meters. The key concept involves three equations for rolling without slipping. First, Newton's second law for translation, F minus friction F equals ma. Second, rotational equation, F times r equals I times alpha. Third, the rolling constraint, A equals alpha times r. These three equations let us solve for the acceleration and friction for any cylindrical object with moment of inertia I. Step 1, for a solid cylinder, the moment of inertia is 1/2 mr squared. From translation, F minus F equals ma. From rotation, Fr equals 1/2 mr squared times A over r, which gives F equals ma over 2. Substituting back, F equals ma plus ma over 2, that is 3 meters A over 2. Therefore, acceleration A equals to F over 3 meters, and friction F equals F over 3. Step 2, finding the maximum acceleration for a solid cylinder. For rolling without slipping, friction F must not exceed mu mg. We found F equals F over 3, so F over 3 must be less than or equal to mu mg. The maximum force is F max equals 3 mu mg. Substituting into A equals to F over 3 meters, maximum A equals to times 3 mu mg over 3 meters, which is to mu g. Therefore, option B is correct. Step 3, for a thin-walled hollow cylinder, I equals mr squared. From rotation, Fr equals mr squared times A over r, giving F equals ma. Substituting, F equals ma plus ma, which is 2 meters A. Therefore, A equals F over 2 meters, and friction F equals F over 2. This matches option D exactly, so D is correct. Step 4, let us verify options A and C. For option A, the accelerations are different to F over 3 meters for solid versus F over 2 meters for hollow. Since they depend on the moment of inertia, A is incorrect. For option C, friction equals F over 3 for solid and F over 2 for hollow. Friction is not always mu mg. It equals mu mg only at the maximum force limit. So C is also incorrect. The correct answers are options B and D. Option B, for a solid cylinder, the maximum acceleration is to mu g. Option D, for a thin-walled hollow cylinder, acceleration is F over 2 meters. Options A and C are incorrect because the acceleration depends on the moment of inertia and friction is not always mu mg. Exam tips for JEE Advanced. Tip 1, for rolling motion, always set up three equations, translation, rotation, and the rolling constraint. Tip 2, the moment of inertia determines the acceleration. Solid is mr squared over 2, hollow is mr squared. Tip 3, maximum acceleration occurs when friction reaches its limit, mu mg. Tip 4, friction in rolling is not always mu mg. It adjusts to maintain the rolling condition. Remember the general formula, A equals F over m times 1 plus I over mr squared. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.